Hey guys, so today what we're going to be doing is we're going to do a science experiment with talking about putting food coloring into a solid, a cold liquid, and a warm liquid, and we're going to be talking about the Movin molecules. And so you've already done your hypothesis, which is your guess on what's going to happen. As we do some of this experiment, I am going to ask you to pause the video and draw a picture of what's happening in each of the cup, and then I want you to write underneath the box of exactly what is happening. And we'll kind of talk about that, and so you can use that to help you with that. Before we do get started though, if you notice, I am boiling some water here. And we're just gonna kind of talk about what is going on, that as I am using heat to boil the water, what is being created. And if you are saying a gas, you are correct. And what is causing the water to turn into a gas? It would be the heat from the stove is making that happen. So we all agreed that the water molecules are heated up, they're going to turn into a gas. This is called evaporation. If I were to continue boiling this water, eventually the water that I had to begin with would not be the same amount if I continue to let this boil, because the water is turning into that gas. Now what I'm going to do is, it's continuing to boil, is I'm going to take a pie plate. I'm going to take a couple ice cubes, and I am going to put this on top of the boiling water. Okay? What do you notice? And I'll kind of show you here in just a second. What is going on with the bottom of that pie plate? Okay? Because remember, the ice cubes, they're going to be cooling this down. So kind of what is going on with that? Well, as I put this over it, it might turn back into water. And yes, the gas is turning back into water. It is condensing itself. What do we notice though? What's it turning into? You can kind of see the bottom of the pie plate. It's turning into little droplets of water, and that gas is turning back into water because I am cooling it. Oh, you might have just heard a sizzle. Oh, there it is again, as it is forming back into, ouch, it's getting a little hot, as it is forming back into that water from the gas. So I'm going to go ahead and turn this off. So now what we're going to do is we are going to start off with the rest of the experiment, and I am going to turn my camera around. Sorry for the mess in my kitchen, but it is what it is. So now what we're going to do is I have 3 cups of water. I have a cup of water that has just regular cold water. I have another one that I put an H on it. It's not necessarily hot water, but it is warm water. And then I do have a cup that has ice. Okay? And so what we're going to do is we're going to take a look. I had some red food coloring, and we're going to start off with the hot, well, not the hot, but the warm water. And what I'm going to do is I'm going to add some drops of water to this cup. And if you notice, oh my goodness, look how fast that went. It spread out really quick and went super, super fast. Okay, why do you think it's moving really fast in that hot water? I'm going to add another drop. Okay, it went pretty fast, and it's probably because the molecules are spaced so much apart in the warm water that maybe that's the reason why it is going down to the bottom of the cup, but it has to do with that warm water. Go ahead and pause your video right now, and I want you to draw a picture of this cup, and you can kind of make a picture of what it looked like as the food coloring was dispersing into the water, and then you can write underneath, why is it going to the bottom and spreading out so quickly? So now we're going to move on to the cold cup of water. So this is cold, and it's actually more room temperature because I can't really get it super, super cold. And so what I'm going to do is I am going to take the red food coloring again, and I want you to watch what's happening as it's going into the cup. Okay, if you know, oh, that's kind of going slower, isn't it? It is going a little bit slower. You would really have to kind of look how you can see that it's just going slowly down. Okay, it's not going to be something that's going to be a really big different notice between the cold water and the warm water. But in the cold water, it's moving slowly, and when it gets to the bottom, it's taking a while to spread out. I mean, guys, look at that center right there. It's really taking a while to get that to be spread out. Okay, I can put another drop in there. And look, just, it's taking a while for it to spread out, okay? I'm gonna go ahead now, I want you guys to go ahead and pause your video now, and I want you guys to go ahead and write your notes about that and draw the picture of what it looks like. Now we're gonna go ahead and we're gonna take the ice. So here is the ice. And what I'm going to do is I'm gonna drop some food coloring onto the ice. Let's see if I can get one that's in the ice cube in the front. Okay. It's moving pretty slow, isn't it? It hasn't quite gotten to the bottom. I know some of the drops might have gone a little bit quickly down, but it's taking a while to get all that food coloring down to the bottom. That is because it is a solid. And it's having a lot of problems being able to mix down to the bottom just because we have those molecules are so compacted together that the food coloring is having a little bit of a difficulty trying to get down to the bottom. You can still see it's still kind of hanging out there. It's not really moving. Okay, so right now go ahead and pause your video, and I want you guys to go ahead and draw this picture of what you see with the ice cubes, and then write about how the ice is moving very slowly, even slower than the cold water.